Okay, I'm going to go through these slides pretty fast because you can always rewind, but the chapter starts out talking about the definition of matter, and we're going to be concerned about liquid, solid, and gas, not plasma so much, and talking about physical and chemical changes to matter. So we know from previous science classes that a solid has a fixed volume, a fixed shape. For the most part, you can change it a little bit, but not too much. Liquids, a fixed volume. Oops, this did not go the way that I wanted it to. That should be over here. A liquid has a fixed volume, but no specific shape. We can pour it into different containers and it takes that shape. A gas has no specific volume or shape, and it will fill whatever container it's in. And if we have a little bit of methane gas in the front of our room, eventually you'll smell it in the back of the room because it fills up the whole container. Solids, not very compressible. Liquids, not very compressible. A little bit, but not very much. Gas is very compressible, and we'll discuss each of these phases of matter in more detail in subsequent chapters. Okay, the main part of this chapter is that we really need to be able to distinguish between a pure substance and a mixture. Okay, and that's going to be a lot of what's on the test. Now, a pure substance is going to be defined by either elements. Now, this is super easy. You're going to get a periodic table. There's one in your book, and there's, I'm sure, one on your smartphone too. And you just look it up. And on the periodic table, there's about 100 different elements, a little more than that, but 100 elements, and you look them up, and that would be a pure substance. A compound is a little bit harder, but a compound is going to be two or more of these elements chemically combined. And that's going to be a big thing, chemically combined, not just mixed, but chemically combined. And there's going to be this exchange of electrons, and that's going to make it chemically combined. So some examples of compounds might be carbon monoxide, carbon dioxide, rust. Yeah, the list is endless. Mixtures. Now, mixtures can be homogeneous or heterogeneous. We'll talk about that. But mixtures are things that are not chemically combined. They're just mixed together. So you could have any amounts that you want. You can make the lemonade as sweet as you'd like, depending on how much sugar you put in there. That's a mixture. It's not chemically combined. It's just mixed together. And it's really important you be able to distinguish between those. Okay, so again, like I said, pure substances that contain only one type of atom. And you are not able to break that down by ordinary chemical means. Obviously, we know with a nuclear power plant, you can break atoms down. But just talking about ordinary high school lab kind of stuff. They can take different forms called allotropes. You should look that up in your textbook or online. And allotropes would be like an example would be the different forms of carbon. Carbon can be in diamond. It's my favorite allotrope of carbon. It also can be graphite, like the lead. I put that in parentheses because it's not really lead, it's carbon. That's the graphite in your pencil. And the structures are different. And again, that's in your textbook, and you should look that up. Here are some things you really need to know for this whole bulk of the class. These are the diatomics, and they didn't come with subscripts. Those should be subscripts. So H2, O2, N2, and then Cl2, I2, F2, and Br2. That's a group in your periodic table called the halogens, and they are all diatomic when they are alone, and that's going to just come up all the time, all year long, all the way through the final exam. The other two that tend to form molecules are S8 and P4, but those are not going to be as important to us. Sulfur tends to get into groups of 8 and phosphorus into groups of 4. The diatomics are going to be super duper important, so if you want to take a minute just to memorize those, that would be awesome. I can give you a couple tricks for that too in class. Okay, another pure substance is a compound, and like I said, chemically bonding two or more different atoms together. Here's the big thing. They always have the same composition, and Dalton came up with this law of constant composition. This is going to be the compound that nature makes up. You don't determine this. Nature determines this. If you wanted to mix some carbon and some oxygen, if you had, some graphite and you had some oxygen you were able to get from a tank or something, you could mix those together. That wouldn't be any problem. But you could choose that mixture. What nature would do if you were to add the spark that makes it react, nature would either make carbon monoxide or it would make carbon dioxide, depending on some environmental issues. And carbon monoxide is when you don't have quite enough oxygen to go around, a limited amount of oxygen. That's why you never want to run a car, for instance, in a closed garage. And carbon dioxide is if there's plenty of oxygen to go around, and nature would determine that. But the big thing is that nature does this, not you. The other thing that's super important is that compounds usually have very different properties than the elements that make it up. So I'll give you just a quick example here. Sodium and chlorine. Notice I make the diatomics when they're alone diatomics. Sodium is a soft gray metal that is explosive upon contact with any type of moisture. In the air, water, it's explosive with water. Chlorine is a deadly gas that is greenish, yellowish, used in chemical warfare sometimes. But if I combine those, chemically combine them, exchange electrons, we get table salt, plain old table salt, which normally doesn't explode at your table. Okay, mixtures, variable composition. They're not fixed like compounds. You decide, okay? They're not reacted together, not chemically bonded. It could contain some elements, some compounds, or both, or more. There are two different kinds, homogeneous, the same throughout, and heterogeneous, different throughout. And that's just going to be for our class what you see. Do you see the same all the way through? Then it's homogeneous. Do you see different parts? Heterogeneous. Okay, so homogeneous, visibly the same throughout. Another term for that is a solution. One thing dissolves in another thing. So salt water pretty much looks the same all the way through. This one gets a lot of people. Careful of this one. Air. Air has a lot of things in it, mostly nitrogen. Of course, some oxygen for us to breathe. Has water vapor in it. Has some carbon dioxide in it. Has some trace amounts of argon and some other stuff. But these are mixed together. They are not chemically combined. This is another kind of tricky one, but solid. What do we do when we get gold jewelry or brass or chrome? We take different metals, we melt them down, we mix them, and we choose what is used. Okay, so I guess I've left out steel here. That's another good one. Steel, it can have high amounts of carbon, it can have low amounts of carbon. We choose that mixture, but then we melt it all together, solidify it, and it looks the same throughout, homogeneous. Heterogeneous, different areas throughout. If something doesn't dissolve in something else, it'll be heterogeneous. So chalk and charcoal don't dissolve in water. So a chalk and water solution, or mixture would be heterogeneous. Charcoal and water would be heterogeneous. Okay, and you can think of some other things. Separating pure substances. Now, if I want to separate a compound, I must use a chemical process because to get it to be a compound, there was a chemical process. So I have to reverse that. Okay? So electrolysis to break down hydrogen and oxygen. How could you break down an element? Well, you can't do that in a regular, ordinary lab. You could in a nuclear power plant. Okay, be careful here when I separate a compound, like sometimes when people say boiling water, that is not a chemical process. I'm not breaking that water down into hydrogen and oxygen. Okay, so we'll talk about that. Separating mixtures is a physical process. There is no chemical process involved because to make the mixture there wasn't anything chemical that happened, so this is physical. Take a minute to look on page 42, read that through on distillation, and also read about crystallization. I'll talk more about this in class, but for the video, you're going to have to read the book and maybe take some time to come ask me about the stories there in Praxair. I will basically say that Praxair is a company outside of Gary, Indiana, that takes air, which is a mixture, and separates it all through a physical process based on boiling points. Okay, also take a minute to look at filtration, take a minute to look at chromatography. These are all separations of mixtures read through and know how to identify them. All right, some changes in matter, physical changes. Molecules move, they might, the thing might look very different, but they don't change what they fundamentally are. So if I make or separate a mixture, that's physical. I do any type of phase change, and that is only physical. If I boil water, I am not breaking it down into hydrogen and oxygen. Hydrogen's flammable. Remember the Hindenburg? Oxygen supports combustion. That's why you can't smoke in hospitals. Well, that's really bad for you. Because those things support combustion. Oxygen supports combustion. Hydrogen is flammable. And so you're not in danger of blowing up the kitchen if you boil some water to make spaghetti, okay? You are not breaking down the water. It's still water. It's just in the gas form. Grinding, cutting, okay. Chemical, though, this is going to change the material's chemical composition. I am exchanging electrons. Bonds break, atoms rearrange, electrons exchange. If I burn something, I react something, decomposing or rotting, rusting, oxidizing, baking or cooking, growing. I think that gets a lot of people. But when you have something grow like grass, that's photosynthesis. You're taking water and oxygen and sunlight, and you are carbon dioxide, and you are making something vastly different. Okay, so properties of matter. Physical, you can test these without changing the material, just a physical change. Color, solubility. Again, if I dissolve sugar in water, it's still sugar. If I do any type of phase change, if I determine the freezing point or boiling point of something, I'm really just physically testing it. It's still what it was. Chemical, though, to test these things, I need to change the chemical. Is something flammable? Well, I have to light it on fire, and then it's not what it was before. Okay. So, is separating a mixture a physical or chemical process? Name some ways of physical separation. How would you separate a compound or an element? Copy the flow chart, page 44 of your textbook.